So, the second report is a report by Oleg Chapila and Halina Klim, please.
Good morning.
Good morning.
Okay, let me start screen sharing. Is my screen visible?
Yes, yes, yes.
Okay, so let's start. For a short introduction, my name is Oleg Chaplia. I'm a PhD student in Lviv Polytechnic University from Specialized Computer Systems Department, and also I'm working with Node.js more than 8 years, and today I would like to present one of my works about it, a self-recovery framework for Node.js microservice. A short presentation plan will be consists of these points. So a short review of microservice architecture, then challenges in microservice development, challenges of specific self-recovery tools and approaches, my proposed approach, summary, and future directions of improvements. So a very short introduction to microservices is that technically we have on the image on the right three images. Like the first one represents a monolithic, then service-oriented architecture and microservices. Of course, we have many other approaches like edge computing or lambda functions, but currently we are based on these three. So microservices is a specific architectural style where we create and compound a system from different services, and each of them executes one specific function or a group of functions within a specific domain. The difference between older service-oriented architecture is in the scope of domains and in the size of service. So micros are just smaller. And of course, first approach monolithic tells that we are creating one big application and push them into the cloud. But this monolithic approach is good when we have only small application or a medium-sized application. When we want to scale or move to a cloud within big systems, so it won't work. Specific challenges that we are having in our microservice development using Node.js are solution architecture design and project architecture. I'll always divide these two things because they have a different scope. The first one is within the scope of overall solution, where we have microservices, additional tools, databases, load balancers, authorization services, VPNs, teams, zones, and so on. So just overall solution architecture. And project architecture means that we are within the scope of one microservice within one project. And of course, the complexity means that it's complex to prepare the system and support it when and maintain the system after 1 or 2 or 3 years of development. Of course, agile challenges are impacting all these things, and we have much more technical issues like scalability, reliability, availability, security, and much more. So currently, we will be only focusing on a self-recovery. So within the scope of Node.js microservices, there are many tools of self-recovery, but they are external tools, and they are based on another things like PM2 or Forever package or containers and Kubernetes. So if we imagine one service, it means that we need to have some external things to manage the health check. And of course, when a system fails, there are many techniques how to replace containers, how or within a bigger scale, how to swap them without any change in uptime or with a little change in uptime. But the current approach is more focused on creating a container within a container only of a scope of a project architecture. So when we are in a scope of a one microservice, we're trying to not to scale infrastructure around it, but create a specific container within the code. So when the file exists, then the service can restart or continue its work without much impact to the service requests, to the uptime, and to the cold start of a service, because we have hot and a cold start. And the current approach exists of three models. So the first one is a system error handler. Second one is user code errors and self-recovery subsystem. On the image on the right, we can see just a generic simplified architecture for it. So we have several clients, for example, load balancer and 3 microservices. So on the next slides, we will only review one service and its internals. Currently, we have several potential error levels within one application. And for my approach, I divided them into three groups. So client code errors, module errors, OS levels errors, and of course, runtime. What we can handle within a scope of one container of a project. We can handle client code errors. We can handle partial and module errors if you have access to them. We can gather OS level errors, because not just runtime has tools to catch process, OS signals, OS errors, and some exception handlers for promises or asynchronous executions. So currently we have user, framework, and not just runtime. Framework code consists of three groups. So currently we are interested in a self-recovery subsystem. This is a place where the main magic exists and how the server is restoring itself. When we move to the next slide, we can see that there is more description for three levels. For system error handling, and then for user code part and self-recovery mechanisms. So user code here, then system, and OS levels, signals, errors, and so on. The main approach for it is to create a specific part within one project, within a framework, a special subsystem. This is a model which will containerize the source code, the user code, and then catch and handle all errors. And if one container can't work normally or crashes, then we can instantly switch to the second container or third container. We can have as much containers as we want, but this approach proposes one thing. The server doesn't need to be taken down or redeployed or recreated, because this costs some time. So the server is always in uptime. The connections are received, they are intact, and they are just forwarded to the second or third container. This is more like a hot swapping within a source code. Then I created a small project, and that project contains two things: the framework code, then some tests, server, and random error generation. For that project, I've tried to start the server, then created a specific script for it. It's called artillery, and the main point of it is just to create a bulk requests to the server and within some scenario, and then check how much requests are failed, how much requests are okay, their time, the count of the successful requests, and much more statistics. There are two screenshots. of it, and the figure 7 represents the execution without self-recovery approach, and image to the right represents with self-recovery approach, and a comparison table based on the previous images. So technically we can see that with self-recovery framework we can have more successful requests, less amount of error refused, connection resets. The overall amount of requests is the same. So we had 1515 requests for both of the test cases, and of course additional things like a time, median, time max, and so on. So as a summary, I implemented that approach, then created test application for it, implemented test case, checked results, and found that that approach works a little bit better within the scope of one microservice and executes faster without the need of a redeployment or recreation of a service in a scope of overall architecture. And future directions for this are investigating of load balancing strategies around that approach, fault prediction, or maybe implementing some AI-driven tools or algorithms to define the potential issues before the server can fail. I think that's all. Thank you for your attention. And if
Thank
you
you
have
very
any
much.
questions,
Thank you very much. Dear colleagues, do you have questions? Alexander Valerievich. So no questions. I have two questions. I have two questions. First one, with which types of applications do you work?
within this specific approach. So this is a server-side application based on a Node.js framework and tool.
No. The sense of question is following. With which type of business application, cybersecurity application, or application for unmanned flying vehicle or another applications, which do you work and recover the errors?
Okay, I got the question. So enterprise applications, information systems, business systems, and more like financial systems. So in the
Okay.
cloud.
And second question, how do you work with such error as infinity cycle?
In the infinity cycle, it just tries to. So there are several containers, and in the infinity cycle, the system will just try to switch a specific count of the errors, and if the system sees that there is some margin received, for example, 5 or 10, the margin may be configured, errors are received, then the system knows, okay, this is an infinity cycle, we will need to stop and and just block that specific API to receive connections, but keep the overall server in uptime. So
But
so it means that we selectively disable one thing to keep the system in uptime.
but how do you recognize the infinity cycle?
For example, on the image on the right, so we can see that one container is broken. So we will switch to the second one. When we switch to the second one and we receive the same request with the same error, it also will be broken and move to the third one. But in that time, the system tries to recreate the first one. And if we are moving towards the first, it's like a round-robin algorithm.
Thank you very much. Dear colleagues, do you have any questions? No? Thank you, Oleg.
Thank you.
So the following